Welcome to ClickMyProject.com. Now we are going to discuss about the project Lightweight Deep Learning Framework for Speech Emotion Recognition. Now we are going to discuss about the abstract of the process. Speech emotion recognition is an important task in the field of effective computing, with the applications ranging from the human-computer interactions to the healthcare and then the customer services. In many fields, speech emotion recognition is needed to be implemented. In this study, we presented a comprehensive approach to SER using the MFCC and then the machine learning techniques. So the MFCC is used to extract the features, then the machine learning is used to classify the features. The primary objective of this research is to develop an accurate and efficient model capable to recognizing and classifying the human emotions based on the speech audio. The user can give the input speech. In this sense, the system model will recognize whether the speech in the conditions of happy, sad or angry, so whatever it is. These features serves as an foundation for categorizing the emotional contents of the speech. We employ the various machine learning algorithms, include the support vector machines, to classify whether the signal is in which conditions. So the final performance of the process will be evaluated by means of the accuracy and error rate in terms of the percentage. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the following steps like input signal, pre-processing, feature extraction, classification, and finally performance estimation. These are the 5 modules presented in this project. At first, the input signal is taken from the dataset. The dataset consists of various signals which is having the various mode conditions. So after taking any one signal from the user side, so the pre-processing will be carried out. In this pre-processing, the signal reshape will be carried out if necessity. In case if the length of the signal is too much high, in the sense the system will take too much of the time to the executions. So that reason we have doing the signal resize. So after doing the signal reshaping, the feature extraction will be carried out. So feature extraction is nothing but the collection of data from the signal. For example, I am giving the input signal. It is having the lots of peak and the intervals. So we have to extract that peaks and peaks everything. So by means of the MFCC method, after extracting the MFCC features from the signals, the mean, standard deviation and variance will be extracted from this features. So this is a kind of the local features we have extracting from the signals. After doing the feature extraction everything, the test features will be generated automatically. Then we have to do the classification by means of the machine learning algorithm. So classification, in this classification it will recognize whether the which kind of speech emotion is this. So we have basically 3 kinds of input to the classification. One is the test feature, then the another one is the train feature, then the third one is the labels. So the test feature is generated from the input signal, the train feature is generated from the dataset signals. So after that, the label will be corresponding to the how much of expressions we have to analyze. For example, if I am going to analyze the 3 expression, in the sense the label will be the 1, 2, 3. Likewise, we have to labeling the each and every categories. After doing the classification, the performance will be evaluated. So the performance will be evaluated based on the accuracy and the error rate in terms of the percentage. So the formula will be calculated based on the true positive, true negative, false positive and false negative. Now we are going to discuss about the running procedure of the process. At first, open the Spider 3.7 and then change the current directory like this. So if you want to execute the file, you have to open the main file.py and then the code will be open. Then you have to click the button run button. After clicking the run button, the process will be starts. Then the dataset will be open. In that dataset, you have see the lots of expressions in that. So we have to select any one signal from the dataset. So after the selection of the dataset, the process will be done automatically one by one. So the results will be automatically shown in the console window. Now we can discuss the results one by one. This is the original signal which we have taken from the dataset. So this is the user defined dataset only, so we can select any signal from the dataset. So after doing the original signal importing, we just doing the filtering and reshaping. So in case if the signal length is high, in the sense we have to do the signal reshaping, or else we need not to do the signal reshaping, directly we just move to the filtering method. So in this filtering method, noise will be removed from the input signal. You can see the peak difference between the original signal and then the filtered signal. So here the difference between the peak signals to the original and then the filtered signals. So after removing the noise from the signals, the MFCC feature extraction will be carried out. So this is the MFCC sample images. So this is the frequency coefficients. After extracting the frequency coefficients, we have to extract the local features from that frequency coefficients. So after extracting the local features, it will be generated as an test features. So after doing the feature extraction, everything, we just move to the classification stage. In this classification, it will detect whether the input speech is an angry, smile, so happy, sad, disgust, so whatever it is, so it will be recognized automatically. The system model will be generated based on the machine learning. So after doing this one, we have to do the performance estimation by means of the accuracy, sensitivity and specificity. So in case of accuracy is above 95 years, it is well and good. So these are the overall results from this process.